In this video, we'll finish the port surface by adding the through hole for the valve guide. We'll then replicate the surface to create 4 instances of the port. Let's open the file PortScan2 from the recent documents list. The splines are visible because we hid them only temporarily using Alt-E prior to saving the file in the previous video. We don't need them, so we'll select all splines and delete them. Let's start by creating a CAD surface from the measured cylinder, which defines the valve guide through hole. This can be measured anytime after the Master3DGage is aligned to the cylinder head. We'll right-click Cylinder 1 and choose Export to CAD. We'll then clear the highlight and view the cylinder. We don't need the point or the wireframe, but we can't delete them because they define the surface, so we'll select them. Choose the Home tab and blank them. Next, we'll extend the cylinder through the port surface. Let's choose the Surfaces tab and then Extend. We'll select the surface and then select the end that we want to extend. The cylinder was created as a draft surface, so we're prompted to extend the cylinder as a NURBs approximation. We'll choose Yes and verify that the default 1-inch distance extends the cylinder through the port. We'll then choose OK. We'll continue by trimming the surfaces to one another. Let's choose Trim to Surfaces from the drop-down. When prompted, we'll select the cylinder as the first surface. Press Enter. Select the port as the second surface and press Enter. We'll then select the cylinder and choose to keep the outer portion. Then select the port and choose to keep the surface outside the cylinder. Finally, with Trim both sets selected, we'll verify the trim. If we're satisfied with the results, we'll choose OK. When we measured the port, we scanned the inside, but the normal of our loft surface is on the outside. We can see this if we choose the View tab and enable Backside. For subsequent analysis and toolpath operations, we'll flip the normals. Let's select the port surface and the cylinder and choose Change. We'll then select both surfaces to reverse them. Finally, we'll press Escape and disable backside coloring. We'll complete the model by creating 3 additional instances of the port surface. The ports are arranged in the cylinder head as 2 sets of symmetric pairs, mirrored along what we've defined to be the y-axis. We'll create the first pair by mirroring the existing surfaces. Let's choose Front View and zoom out. We'll then window select the model or press Ctrl-A. Finally, we'll choose Mirror from the context menu. We'll add a mirror of the original, so we want Method Set to Copy. The port openings are spaced along the y-axis, so we'll choose that option and fit the screen. We can set the mirror plane by clicking in the graphics window, or we can enter the offset along the axis. Based on the spacing of the engine block bore center line, the plane of symmetry for the first 2 ports is 4.4 inches from the origin, and the second is 8.8 inches beyond that, so we'll use the sum of the values, 13.2, as the offset. We'll then press Enter and choose OK and Create New. For the other pair of ports, we'll press Ctrl-A to select the current pair. Press Enter. Change the offset to 8.8 and press Enter. This positions their plane of symmetry 4.4 inches from the origin. We can now choose OK, clear colors, and review the model. The reverse engineering process is now complete, so we can save the file. In the final video, we'll compare the scan to the finished model to check the surface accuracy. To see the difference, visit us at Verisurf.com.